Hello everyone. So I'm Gautham, co-founder and CEO of Polkadex, and I want to talk about a niche problem in Substrate, and especially working with Polkadot, because most of the engineers who are developing on Polkadot mainly work on the runtime. But there are some niche cases. For example, in our case, we have a long-running computationally intensive and generic computation. That's what we wanted to do, and that's our requirement. But the thing is, it's not easy to do that in the inside the runtime. And we also needed access to networking and all the other components that we have that we need to make the Polkadex order book work. And yeah, I mean, most of other teams and other projects use zero knowledge proof, but zero knowledge proofs are not yet created for generic computation. It's not available for everything, and it's also painfully hard to build build using zero knowledge proof, and also it requires like special expertise to build that. And obviously, like at the end of the day, when we are building something, we want better Nakamoto coefficient, because we want like all of the validators to verify and test and attest whatever the logic that we want to run, the business logic. So yeah, I mean, talking specifically about Polkadex and our journey, like we needed the order matching logic to be executed by all validators, but it was too slow and expensive to run on chain, because back in 2021 we did that. We created the business logic on chain, and the biggest problem was it took obviously 6 to 12 seconds for inclusion, and also we can only have like 1500 transactions in a block. That's more like very few transactions per second, which is not possible, especially when you're building a high frequency trading order book. So yeah, and we needed to gossip the orders and trades between all the validators and all the nodes, so that we have data availability. At the same time, we want to make sure that all the trades are being verified by the validators, and we need to do it at scale. That is like 1000 orders per second. So we had three options. So runtime obviously won't work. So we can either build it as a sub protocol, that's something similar to Grandpa or Beefy, or the Bay protocol in on the client side, or we can use off-chain worker or runtime task. Runtime task is something relatively new. It's not not particularly useful in this context, but it's more towards housekeeping inside the runtime. But I'm not going to get into that, because it needs more documentation, and it needs more. It's not mature yet. So so what we did is we reverse engineered and basically went line by line on the Beefy code to understand how to do the client side, because in Substrate there is not enough documentation on how to create client side palettes. It's more focused on or biased towards the runtime development. So we had to take the hard route, and we have to go through line by line of the grandpa logic, and also the babe logic, and also the Beefy logic. So that was the biggest problem and biggest time waste for us, because there is not enough documentation. We had to go through this, and that's the reason why I'm doing this presentation today, to point out, because there are these niche applications where having such a documentation will be helpful. I understand that it's not used by everyone, but for example, if we need to do like external voting for like a governance platform, someone like Polka Assembly, or someone people who do that, they can use this. They can do a decentralized off-chain voting instead of having the voting being on-chain, and it's costing something for the users. That's just an example that I'm giving, but there are certain use cases where you need high frequency state changes, or high frequency of interaction between validators to finally make a single state change. So let's get into the client side palettes, and what was our experience with that. And it's mainly like it's very easy to work with that, because it's pure Rust. There is no macro. There is no like relatively less macro, and it's not like put in a fixed type system or something like that. Something like a runtime where we have to follow certain structures and patterns to make everything compile. So it's much easier to work with. Obviously, Tokyo is available, and you can access all the standard libraries, and also you have access to Gossip Engine. In the code samples, I will show like what all things are available in this client-side palettes. At the same time, I also want to point out the disadvantages of that, because with client-side palettes, you cannot do runtime upgrades. When I mean by runtime upgrades is, like, let's say you make a bug in the code in the last release, and you need to update that. Now you need to wait all the 51% of validators to upgrade. So that typically takes like 3 to 4 weeks. So the iteration, the speed of iteration of your product will be like significantly slower than runtime upgrades. Runtime upgrades, obviously, in governance, it takes 1 month, but that's more like on a political level, or like or an consensus level, on whether we need that upgrade or not. But when you need to make bug fixes, it should be it should happen faster. And that's not possible with client-side pilots, and that you can see that with the deployment of Beefy. I think the Snowfork team was talking about it yesterday, and it's still at 50% upgrade stage, upgrade completion. So only 50% of the validators upgraded so far, and they need to cross 67% to actually activate Beefy in Polkadot. So the same problem applies to anyone who is working with client-side pilots. And again, this code is not secured by the runtime. So the validators, in theory, can modify the logic and run their own, variants of the logic, potentially attack the system also. But as I mentioned, earlier, you have all these access. So if your business logic can build a certain protection and safeguard against all the disadvantages of client side. For example, like a on-chain voting. Like, let's say every validator will process something, create a result or a summary of that computation, and all the validators vote on that summary on-chain. So that you can have a consensus on like everyone execute, and like the majority of the validators agree on the same thing. So that's basically like because see, there are a lot of nuances to these client-side palettes and the topics that I'm covering here, but I cannot get into all those now. But these are the high-level points that we need to keep in mind when we are working with client-side palettes. I'm calling it client-side palette. It's not technically palette. It's more like a crate or a library that you can put into the service file of the node. Where it will run as a sub-protocol along with all the other protocols like Grandpa, Beefy, and Babe, and etc. So, talking about our experience, it was relatively easy to build, as we mentioned, and we shipped things faster. But again, we ship things faster, but if something happens, then it takes 3 to 4 weeks for the the community to get the community to upgrade to the new binary. So it was painfully slow, and during that time, you are exposed to that particular bug or whatever the problem that you are trying to fix. And so last year it happened to us because we were using this. We had a decentralized order book where the trades and orders were gossiped across the whole 200 validator set. And there was a spike in the number of orders, and it nearly killed our blockchain. And for approximately 30 minutes, the blockchain was not producing blocks because the entire gossip network was overwhelmed by the number of orders coming in. And that's another thing to think about, because if you use gossip, it's gonna be a pain in the ass, because it's gonna you have to fine tune it as much as possible. If that's not possible, if you cannot do that, do not even use gossip, because it's gonna kill your blockchain. So that's a big disclaimer for using client side. But if you don't use gossip, but you just need to do long running computation, like generic computation, and then submit something on chain, then it's completely fine to use client side, and you can make it happen. If you can make it happen. So you can scan this QR to to get to the code that I'm going to share. Yeah, okay, yeah. So I hope it's clear. Okay. Let me know if I need to zoom it. But anyway, so the point here is, this is one of our older releases where we were using the client-side logic for order book, where like all the entire order matching was happening with the validators, including the order book was sitting with the validators. And here you can see like we have so we have the normal the palettes where you have the you have the normal on-chain runtime logic. And also we have a separate section called client-side palettes, which contains like order book and Thea. These are like two features that we had. And inside order book, we have a worker which basically runs along with the babe and grandpa, and it listens on finality notifications from the block production and the finality logic of the substrate chain. And whenever the finality happens, we take that as an input or as a tick to do some action. And in our case, it was to aggregate all the orders, compute the traits, and then finally submit the state transition. That is like how much balance was increased for whom, and how much balance to decrease for whom, and all those. That basically the state transition of an order matching and an order book. That's what happening in this worker. But the main thing I want to point out is, so it takes a set of parameters before the worker is created. Here you can see this is how the worker was created. And like you can see here, like the client side backend runtime key store. So runtime and backend basically gives you access to the client, the nodes tooling to access the different storages and the different set of features that the substrate node has. At the same time, you also get access to key store. That is the raw key store, the underlying key store, where the babe keys, grandpa keys, and all the other keys are stored. So you get access. You can access these. Basically the cryptographic keys are stored here. And if you have a special type of cryptography that you want to use, for example, like we wanted to use BLS because it was way before the substrate started to support BLS signatures, and I think even now the BLS signatures are in an experimental stage. So we modified this, the key store container, to bring our own key store implementation that supports BLS, and then we can use that. So you get these kind of low-level access when you work with client side. And also you can see here the network access, and that will help you to create a gossip engine. That will be the input to the gossip engine, and then using which you can start gossiping to all the peers and do your own peer management. And then sync is basically the sync service, which takes care of whether the service is syncing or not, the blockchain is syncing or not, and you get some kind of information into like if you are like syncing older blocks, do you want to do something? If you are syncing the latest block, then if you want to do something else, like those kind of differentiation can be made using that. So in short, what I'm trying to show is like when you integrate this into the service file of a substrate node, it can be even a collator, doesn't matter. It works the same way. You get access to all these features, which if used in the right way can help you a lot in terms of building new features for your product. And I will show, so this is the worker logic where, the same thing, you get some of your state and also the, the handles to the gossip engine and all the other parameters that you wanted to access. And the core of the logic happens in the run method. So here you can see like this is the run method. So the nuance when building with client-side palettes is you have to release your binary, the validator binaries, before you release your runtime palette, because if you're using some host functions or some other features like that, the binary should have support for that before the runtime is upgraded. So you have to release the binaries, let's say 2 to 3 weeks ahead. So that the validators upgrade, and majority of your validators, like that is 67% of your validators upgrade in time, then you do the runtime upgrade. So basically the first statement in this run method is saying that, okay, wait for the palette to appear on the runtime, only then continue forward. Otherwise wait, just sleep, don't do anything. Because there's nothing to do, because even if you compute something, there is no associated palette in the runtime to do something about it with that result. Then you can see like I'm using the same handle that I showed earlier to wait for the blockchain to complete, because in our case, We don't want the nodes to operate on any data until the nodes are fully synced. That is if you're syncing from scratch, like you need to reach the best block before our protocol starts. So in our case, we have to wait for that. And then this is using the runtime handle. We can get access to the runtime APIs and the runtime storage in a trustless manner. So that's how these are the features that you get if you are using client side, because there is a lot of flexibility and also a lot of freedom to build your own logic and your own structures into this. And the main thing is, so here you can see this is the gossip engine the gossip implementation that we were using for order book. And there you can see we are creating a stream of messages, notification messages, through which the validators, for example, in our case, the user will submit an order using an RPC, which will be gossiped across all the validators, and that notification, that message will come to each node through this handle, this notification handle. And then we can decide what to do with it. If it is a place order, we do in a certain way. If it is a cancel order, you can you can take basically based on your business logic, you can take an action. And then the finality stream, which basically says, okay, this basically hooks into the grandpa finality gadget, and it basically says that, okay, a new block was finalized, and this is the block number or the block header of it. And with that information, you can take some actions. In our case, it was like, let's say someone makes a deposit into the order book, and you need that block in which the deposit happened to be finalized before you make a state change on your client side palette. So that's basically similar idea is applied there, where you get some source of notification for whenever a block is finalized, and act based on that, based on your business logic. And all these components are then packaged into one big future select macro, where all these individual asynchronous functions can trigger at any time, and then you make a decision or you make a business logic state change according to that. And so this is, rest of the logic are specific to our domain, so it doesn't really relevant in this under this topic. But basically, this is what this is what we get in terms of features when we work with the client side. The main thing to note here is fine tuning the gossip. I think Gavin was also talking about this earlier, this talk, because they are also trying to minimize the use of gossiping, because gossiping is really hard to make it work. Like if you have a perfect tuning of the gossip engine, then it's fine. But if you have like similar to us, if it is like high frequency trading based logic, then gossip will probably hurt you than helping you. So that basically applies here, the gossip validator, where each incoming message is validated and checked against the state, the local state, and see whether this should be allowed to gossip further propagated into the network or not. So you have the process and keep, discard, discarding the message based on your business logic. For in our case, like if an order is given by some user and it is not yet included, we will propagate it to others. But if it is already included, it's like, let's say an order was gossip to a particular node, and that node already processed that, and that node sees that, okay, this order was already processed and settled, and it has nothing, no more, it's not relevant anymore. Then instead of propagating it again and consuming more bandwidth, you should discard that. So similar logic was there. And this is the part where I was talking about earlier. Like this is the trait that you need to fine tune so that you don't kill your blockchain, because it happened to us. And fortunately, we were able to get it back by rolling back the upgrade. So yeah, so that's basically it regarding the client-side palette. And the second option, the more safer option, is off-chain workers, because there are trade-offs. Because in our case, we had to centralize the order matching engine, so that instead of gossiping all the orders to everyone, we do a preemptive computation of the order matching, and then let the validators recompute and verify whether whatever we did in off-chain is same as is correct and it's not fake, and there is no need to trust us. So that's why we did the we use the off-chain workers. And here off-chain worker is a piece of logic that is part of the runtime. But when I say it's part of the runtime, that doesn't mean that it is trustless, because the output of the off-chain worker is not deterministic. That is, it's non-deterministic. It has access to random functions. So that doesn't mean that like every node will have the same result after running the off-chain worker logic. But the point is the core logic is supported. It's secured by the runtime. Like you can have a guarantee that okay, what is running, that is secured by the runtime. And it can do HTTP requests. No streaming is available, but still you can access outside systems. So this is the comparison I want to draw here, because in client side you can do streaming, you can do gossiping, you can do pretty much anything that you want to do with networking. But in off-chain worker it's limited to HTTP request, and you have access to randomness, the local randomness from the OS and all those things. Again, so you have a trusted in a trusted manner, in a trustless manner, you can access the on-chain storage, and also you can access the off-chain DB, which is like a temporary storage that you can use during the off-chain computations. And the biggest disadvantages of off-chain workers is, in our case, we had to use, we wanted to use certain standard libraries. So we have to organize or restructure our code base in such a way that we are not using STD based enabled libraries. So it's a no STD environment, no gossip engine access. You are limited to HTTP requests. And for off-chain workers, the testing framework in Substrate is not yet mature. Like, there are a lot of bugs there, and we have been struggling with that for some time, and we have to come up with our own ways to test it. And we do plan to contribute it back to the Substrate framework so that other people can also use that. And the storage capabilities are also not feature complete. In fact, we found a major bug in one of the storage trees used by Polkadot, and we submitted a PR like a few months ago. So these are the main problems with off-chain workers, because it is relatively less used compared to runtime, so there is not much activity there, and that's why there are the framework, the testing framework, and the storage capabilities are not like fully tested and not fully mature. So that's something we have to keep in mind. But I would say this is the best, the first iteration that you should try if you cannot do your business logic in the runtime. And off-chain worker was the winner for us, because it allowed us to go to market faster. And in fact, like I said earlier, like whenever we found a bug, we can quickly do a runtime upgrade and make sure that everyone is upgraded, instead of waiting for 3 to 4 weeks for validators to upgrade the binary and then have that change, have that bug fixed. So like I mentioned earlier, like in our case, like we have this off-chain component which will do preemptive computation of the orders, and then that using HTTP request, that will be fetched by all the validators and all the nodes, and they will re-verify, and if they find any bugs, they will submit it to runtime and dispute over it. And if everything is fine, they submit a summary on chain which is voted by all the validators. There we have like 64 super majority voting, and that gives us strong security guarantees that okay, the state change or the computation happened over the off-chain worker is correct and accepted by the network. And you can scan this code to to get the code that I'm going to share, just to give a sample on like what's happening here. All good? Okay. So it's the normal off-chain worker hook that we are showing here, but we have this run on-chain validation function, which basically is a one big long function that we have. But here the main difference is, as I mentioned earlier, we have access to the local keys, but that is like in client side we have the raw key store, so that you can inject your own application specific keys, and you can write a trait over it and implement your own custom keys. But here you're basically limited to what Substrate supports. But in our case, what we are doing is we have an authority, like a section key specific to our off-chain workers, and like we are loading all those keys, and then we are getting the list of validators from on-chain, and then we are checking if we have a if this particular node has the key or the active key to participate in the protocol, and if they are a validator or not, that is available. And then so basically what you're doing here is, if you have the right key and you are an active validator in this current epoch, then you can do the following computations, verify the logic, and then submit a summary back to the runtime saying that, okay, I have attested this, I have verified, I'm attesting this particular snapshot or the state change. And this is done by all the validators. So we have guarantee that, okay, this is the exact same code executed by all the validators. And if we get like, 67% of the signatures from the validator set, then cool, that state change can be accepted by the runtime. So I think you can see a general trend here. Unlike the runtime logic, like even in client-side palettes and also in the off-chain worker, you have to do some kind of voting on-chain with all the validators to ensure that the computation is trustless. And this is the way we bring security, because it's same as Grandpa. Because what Grandpa is doing is, it's doing that voting off-chain. I mean, not off-chain, like it's on the gossip layer, so that they collect all the signatures from the validators regarding the finality of a particular block, and they put it together and then finally decide, okay, this block is finalized because super majority of the validators have seen this block and accepted this block. The same idea happens here, where all the validators verify the state transition generated by the order book or your business logic that you're building, and they all attest using signatures that, okay, I have seen this, it's good, let's proceed. And once majority accepts, then we know that it is finalized, it can be finalized. And so, and rest of the logic is basically like specific to us, and like you can go through that. It's basically doing all the checks on the orders and trades that we did, and then finally creating a snapshot summary. And then that summary will be submitted back to on-chain. And let me show you the how to send that summary, because in this case, yeah, so we have this submit transaction function from like the frame system off-chain module, using which you can call an unsigned, you can send an unsigned transaction to call a particular extrinsic on-chain and then submit your data through that. So with this, the basic idea is, like the voting that we are doing currently is on-chain, unlike Grandpa, which is happening in the gossip layer. And this gives the security guarantees on-chain that, okay, this computation has been verified by, this particular authority, that is the validator, and this is their, the signatures, or whatever it may be in your case. And that gives certain level of like the maximum security guarantee, just like Grandpa, on your computation. And essentially what's happening here is, you get access to like long running computation, generic computations that you can do, completely off chain. You don't need, you're not limited by the runtime's execution time, that is generally like 3 seconds or 4 seconds or whatever it may be. And you can obviously run like long running tasks and non-deterministic task. And then you can have your own concept of state transition, and that will be finally accepted back into the runtime for further execution. So this is how we did it. We leveraged the client-side palettes, and I really hope the rest of the team who are going to use this provide more documentation and provide more support for it, because this is a niche area, and there are not much people using it. And as a general conclusion, what I wanted to share is, if you're a new team, don't go to client side immediately, because it's gonna get super hard. That was our experience, and with minimal documentation from Substrate, it's not possible to build something as quick as possible. So the moment you find that runtime is not good enough for you, then you can use off-chain workers first. Try it out there, experiment the idea there, and then once you have clarity over what are the requirements, Like for example, you need to have like, let's say, like 5 megabytes of data transfer between validators, or like you need to have like strong network relationship between all the validators. Like all those business level requirements are clarified, then you can start building the client side palettes, and then fine tune it so that you don't kill your blockchain, and then make a really fantastic product. And before I conclude, I just want to show one more thing. So this is our mainnet. So whatever I was, instead of just showing you some bunch of theory stuff, I just want to show you in live action. This is one of our validators. So it's running the off-chain model, off-chain worker model that I was talking about. So you can see like the validators are fetching the batches of data, trying to fetch batches of data on every block from the off-chain component, the order book, the order matching engine, and the error that you're seeing is just so that it's clear to everyone. It's just there are no snapshot available at that block. But if you wait for a little bit, you can see this is connected to our mainnet. So these are the live trades the users are making in our network right now, and yeah, so we got a bunch of trades. Now, those trades are processed by this particular validator, and they just submitted a state transition to runtime. So that was like validator number 142 or something. Yeah. So this is basically the idea behind the whole the next example, a real life example of what I was talking about. So you can see like there was like bunch of trades, like probably like 4 of them that was executed in this particular batch by the off-chain component. And yeah, so this particular validator verified that trade and checked for its authenticity and all the other verification on validation that we need to do, and updated the off-chain state. Then finally, it submitted a snapshot, back to the runtime. And this is how we implement the Polkadex order book, and this is how it provides the same level of security guarantees as a runtime palette, because runtime depends on grandpa block production and grandpa for finality node and finality and the security guarantees. This also assumes the same security guarantee where all your validators are super majority of your validators are voting on the state transition that you did. And just like the runtime, you have access to you can do a runtime upgrade and update the off-chain worker logic. So yeah, so that's that. And is there any questions?
Is there any tutorial for getting started with the client-side palettes?
There are not. That's what I was talking about earlier. Because when we started out, like there's not even tutorial, not even a documentation on how to do this. So we depended on a lot of individuals from Parity to get support on this, and basically we have to reverse engineer the grandpa palette. And I think the beefy palette was getting started back then. It was like 2 years ago, something like that, and we have to go through the code line by line. And I can understand that, because majority of the teams are working on the runtime, and this is not really a priority, and there are not many teams who require like long running task or generic computation. So I can understand that, but this is really sad that like there is no documentation on it, because if you have this well documented, there are a lot of use cases that can be built. Like I just cooked up this. Like if you have like a governance platform, you can have the external voting. Like right now, like instead of voting on chain, you can get the pulse of the community by having a gossip layer running the votes, and in real time update the interface, showing that okay, this is happening, that is happening, and give you a sense of okay, whether if I put this proposal on chain, what will happen. That can be done instead of making it a centralized platform. So that's something that we can definitely do. I mean, some other teams can do, not us. For us, order book was the biggest reason why we wanted to do this, because you can definitely build an order book on chain. That's not a big deal. You can do that because we did it in 6 months. But again, 12 seconds of latency. 12 seconds of latency on each block production, that doesn't really make sense, because if you compare to centralized exchanges, executions happen in milliseconds. So if you need that, okay. Oh, okay. So if you need that, you need, these kind of low level access to these components to make that happen. So yeah, any other questions? Okay. So yeah, you can reach out to us in the bigger QR and learn more about Polkadex, and you can reach out to me with the smaller QR, and I can help you out, because we definitely went through this process, this whole development journey, and it'll be much more easier, easier for others, if we can work with each other and share our experiences and share notes. Yeah, I think that's it. Thank you.